Hello students, my name is Kumari Neha. I am working at Bharathidhasanar Matriculation Higher Secondary School, Arakkonam, and the topic for today which we are going to see is from class 9th standard and it is from chemistry, and the name of the lesson is chemical changes and reactions. So students, today we are going to see the third part of this lesson. Previously we have talked about the 4 reactions, that is dissociation reaction, combination reaction, thermal decomposition reaction and replacement reaction, right. So now let's see the 5th point. So 5th type of reaction is catalytic reaction. So here you should know there is one point. Here the main role of this reaction is to give the answer, that is the product, with a help of a person. That person named is catalyst. Okay children. Now here the definition is a catalytic reaction in which the rate of reaction is altered. Here the rate of reaction altered means here it is fast or it will be slow. Okay. In the presence of catalyst is the main element in this. Okay. It is known as catalytic reaction. Now what is a catalyst? Catalyst, I said that it is a helper, it is a hero in this. So the definition of catalyst is a substance which does not take part in a chemical reaction, that is it will come and go but it will not play a role to give the product, that is you will get the answer for that, but later on when you are getting the product, that time there will be no catalyst present in the product, right. Now let us see what is catalysis. See children, whenever you are using a catalyst and it is changing, that is it will accelerate or deaccelerate. Accelerate means fast, deaccelerate means slow. When this is happening, this process is known as catalysis. What it is known as? Catalysis, right. Now for example, AB wants to shift to the place called CD. Now they can go through 2 ways. One way is like zigzag, zigzag, zigzag. So this is a longer way, right? But this plumber wants to finish the work very fast. So how he will finish it? He will take the help and it will get a shortcut. Shortcut means it's a faster way, right? So here the catalyst, here is increasing the rate of the reaction. That is, it is fastening up, right? Now see in this diagram children, the first diagram is showing that there is a black particle and a red particle. Now this red particle and black particle is known as the starting material. Now what is happening, when the catalyst is introduced in that, then in between the catalyst, here there will be a place. Now here is black one, yellow is the catalyst and the end is a red one. So this is known as a intermediate. After intermediate, you will get directly the product. So product is what? Product here is half black, half red, and the catalyst is coming out. So this is the main intermediate thing which we are going to see in catalysis reaction. So 2 things are there. So catalyst can fasten the reaction or it can slow the reaction, right? So when a catalyst is slowing the reaction, it is known as negative catalyst and inhibitor. So let us see what is the definition of this. Definition is a substance which slow down the rate of reaction or retard the efficiency. Retard means it will weaken the efficiency, then it is known as a inhibitor or a negative catalyst. Same way promoter. Promoter is what? People are saying, right, you got promoted to the next class, right. Right now you 8th standard, you came to 9th standard promoted, that is you came up. So how to fasten the reaction? Here the substance which is used to fasten the reaction is known as a promoter. Okay. Now let's see what is the positive catalyst doing here. Now in this reaction you are having potassium chlorate. KClO3 is potassium chlorate. When this is heated, that time it will give the reaction potassium chloride and ozone. O3 is what? It is ozone. Same way here when you are taking the negative catalyst, that time H2O2 which is hydrogen peroxide in the presence of platinum. Platinum here is a inhibitor. It will give water and oxygen. Same way now we are taking here a promoter example. Now this is a reaction. In this reaction here you can see that we have taken nitrogen and then hydrogen Now, when these two we are combining together, automatically this will not get combined, okay. So, how they will get combined? They will get combined using the catalyst known as iron. Now, this iron, due to the presence of this iron, you will get the initial mass which is known as ammonia, and the heat will get liberated, right. Here, the reaction will be too fast, but you need even more faster, you need to promote it. So, here promoter you are using is molybdenum. Molybdenum is an element, okay. It is present in the periodic table in the center, that is D block elements. Now, in inhibitor I said what? Yeah, Sanjana, what did I say inhibitor? Yeah, very good. Inhibitor means it is slowing down the reaction. For example, in the manufacture of sulfuric acid, what is the formula of sulfuric acid? It is H2SO4. Now, you want the product as H2SO4. So, here you are using platinized abistol as a catalyst, but you still want to slow down the reaction. So, you want to poison the reaction. So, that inhibitor which you are using here is arsenic oxide. Okay, children? So, that is why this is also known as a inhibitor. Here the example of inhibitor is arsenic oxide, right. Now, let us come to the next process. In the next process, here it is reversible reaction. So, what is a reversible reaction? It will show that the initial reactant will go back to the product, and the product again it will come back to the reactant. So, this is known as a reversible reaction. When the reaction is giving a product, it is known as forward reaction. Same way, when the product gives back the reactant, it is known as backward reaction. For example, here again we are taking nitrogen and hydrogen. When these two combine together, at this particular molybdenum is what, children? It is a promoter, and Fe is what? Fe is iron. At the temperature of 450 degrees Celsius and 400 atmosphere, it will give ammonia, and automatically it will convert back into the nitrogen and hydrogen, right. So, there is a point in this. What happens whenever we are doing the reaction with the case of gases, we should close the container, because if any one product or any one reactant also escapes, then you will not get back the backward reaction, right. Now, let us come to the thermal dissociation reaction. So, Vishwanath, you asked me a question. So, Vishwanath, here I will tell you, thermal dissociation is same as dissociation reaction. There is only one difference in that. The difference here is this symbol. So, this symbol is heat symbol, okay children. Now, here again dissociation is happening. AB will dissociate into A plus B only when the heat is provided. Now, see this reaction. This is ammonium chloride. Ammonium chloride will give the reaction of ammonia and hydrochloric acid only when the heat is provided. Same way here, pentachloride you are taking phosphorus, pentachloride. When you are heating it, that time only it will get dissociated into phosphorus, trichloride and chlorine atoms, okay. Now, let us come to the last reaction in this. So, this reaction will tell you what is a redox reaction. So, children, before going into the deep redox reaction, we should know what is oxidation and reduction. So, now let us see here, children, what is oxidation. When a substance gains oxygen, that is, here you can write it as gains oxygen means plus O, and loses hydrogen means minus H, the oxidation of the substance takes place. Here O is coming and hydrogen is going, right. So, that is why oxidation, there is a trick. O means O will attract O, right? So that is why O is coming, oxygen is coming and hydrogen is going. Same way, here there is removal of electron too. Same way, now come to oxidizing agent. See, the person who is making the oxygen add is known as the oxidizing agent. Now let's see what is the definition of it. The substance which loses. Here oxidizing agent is oxygen is lost and hydrogen is gained. This is exactly opposite, right? So there you should understand what is oxidization and oxidizing agent. Only then you can understand the difference between reduction and reducing agent, okay? Here there is negative O. Negative O means removal of oxygen and addition of hydrogen. Same way, now let's come to the reduction. Just tell me oxidation means plus O. So reduction means minus O. There in oxidation it is minus H. So here it will be plus H. Same way here electrons will be added. Now let's come to the reducing agent. So when you are seeing the reducing agent, you can compare it with this, okay? Oxidizing agent, it is exactly opposite. Here minus H will be there because here it is plus H and here plus O will be there. So children, here H is the hydrogen, O is the oxygen, add means it is gaining, negative means it is losing. Understood this concept? Yeah, very good. Now you can see one more thing in this, that here see in the case of removal of oxygen, or you can call it as electrons. So this is the initial product. Now when an electron is going from this, it will become an electron acceptor. So this electron is going, right? So this process is known as oxidation. Oxidation is what? Oxidation is addition of oxygen and removal of hydrogen. Same way here it is accepting, right? It is accepting an electron. That is why this is known as an reduction reaction. Reduction reaction means addition of hydrogen, removal of oxygen, right? This is a basic thing in which you should understand. Now let's see this one example, okay? Now in this first example, CuO is copper oxide, H2O is hydrogen. When it is heated, it gives copper and water, right? Now here oxygen is getting removed, right? So O minus. So O minus is reduction. Same way in H2O, oxygen is added. When it is added, it becomes oxidation, right? Now see here, as the hydrogen gains oxygen from copper oxide, here hydrogen is taking oxygen and it is becoming water. So here hydrogen is getting oxidized. Same way, when hydrogen is gaining oxygen from copper oxide, that is why hydrogen is also known as reducing agent. Same way, copper oxide, here copper oxide is losing oxygen and it is becoming Cu. So this process is known as reduction. Same way, this copper oxide will be known as a oxidizing agent, right? Now let's see what are the tests. So here first test, they are telling that whenever they are taking a product and in that if O2 is coming out, oxygen is coming out, that means this is a oxidizing process. Same way here, when they are doing the concentration HCl, that time Cl will be coming out, again it is a oxidizing agent. And same way for bromine, it will give bromine gas, and in iodine it will make the solution of KCl as brown solution. And here children, whatever is underlined na children, they are known as oxidizing agent. Oxidizing agent is what? It is taking out the hydrogen from that, okay? Same way, now let's come to the reducing agent. In reducing agent, first FeCl3 plus H2S will give FeCl2. Here again the liberation of sulfur is there and HCl is there. It will be little light green in color, and in the second process there will be NO2 gas. When the reaction is done with HNO3, HNO3 is what? It is nitric acid. Same way here when you are seeing, here acidified KMnO4. What is KMnO4? Potassium permanganate. Now the color changes to purple to colorless. Okay, this solution is normally in purple color, but when this reaction is taking place, it will become colorless. So this is also showing that it is getting reduced. Same way, last is potassium dichromate solution gives a green color. So here when the reaction proceeds, it will give a green color. Now children, here whatever I have underlined, now here FeCl3, carbon, HCl, and here also HCl, these all are reducing agent, right? Now let's see what are the conditions for that. Now first condition is there should be a close contact between them. Here it can be processed by grinding or it can be dissolved in water. So this is the reaction. Here Ki is what? Potassium iodide, and HgCl2 is mercuric chloride. Now these two are white in color, but when I am grinding it, it will become, see color, what is this color? This is deep red color. Same way, now come to heat. Students, when you are heating it now, that time also the process gets even more faster. Here potassium chlorate converts into potassium chloride and oxygen. Same way here, sodium nitrate, NO3 is nitrate. When it is heated, it becomes potassium nitrite and oxygen, right? Third is light. So using light also many processes are done. So first is H2 plus Cl. In the sunlight it will give HCl. What is HCl? HCl is hydrochloric acid. Same way, this is what reaction? Can you tell me what is this reaction? Okay, Vandana, you tell me what is this reaction? Or else Aishwarya, tell me what is this reaction? Yeah, very good. This is a photosynthesis reaction. So in this also sunlight is required and chlorophyll is the pigment which is present in the leaves. Same way, here fourth is pressure. At a particular pressure only, some reactions will take place. So N2 plus H2 and N2 will combine together to give ammonia at a particular pressure, that is 150 to 200 atmosphere, which is the pressure. Temperature will be 450 to 500 and the catalyst should be iron, right? And the last one is catalyst. So here when you are seeing, whenever catalytic agent, so catalyst we have talked about it, right? Now here in SO2, this is known as sulfur dioxide, reacting it with oxygen, it will give sulfur trioxide. Tri means 3 oxygens are there at the presence of platinum arbisot, and the temperature is fixed, that is 450, right students? After that, it's electric current. Now electric current, there is only one very big example, okay, that is electrolysis of water. Here what we are doing is we are passing electricity in the water. When electricity is passed, it gets splitted into H2 and O2, okay. So okay students, so now I hope you have understood till here that whatever things we have discussed. In the description box you can go to the YouTube links and study material, question bank and self-assessment. Self-assessment go once you are thorough with the lesson. Then you can get to know how much you have understood the lesson. I hope you have enjoyed the class. Bye-bye.